What's up, world? Let's get back at it. I'm Tui, and I am going to be talking today about some more graphic stuff, except this time we're going to do key input, so it's going to be a little bit more, Swift based. Anyway, before we get started, I just want to say that yesterday, let's do this, Apple announced Metal 2, and so I've already kind of taken a look at this stuff. It's pretty sweet. I don't know if it's going to leave any of our code deprecated. We'll have to find out, and I'll just go back and I'll make some edits if I have to. But it looks like they're actually going to have an external graphics development kit, so you'll be able to plug in your GPU and utilize that for developing and for accelerating your graphics. Pretty sweet stuff. So you can look into that, check it out. I'm going to wait for some more of these videos to come out before I start diving too much in it. I know they have these metal performance shaders, which are pretty badass, but I think these are more for phones. I don't even think Macs support metal performance shaders, but we'll just have to wait. I'll see. But in this case, today, we're just going to do key input and work with the camera. Finally getting that camera in so we can start moving around the scene. Basically, the way the camera works is pretend you have a video camera, like a legitimate video camera. And you have the eyeball right there at your eye, right? You have that lens right there at your eye. Well, when you move the camera, you're not actually moving anything around you. It's not some magical device that, levitates things and moves them across the room for you when you move your camera. Pretty sweet. If you make that, you're going to make a lot of money. But what it does is the world rotates around the camera. Everything around the camera is moving. It's not moving. It's just shifting off the screen because just pretend like all of those are mathematical formula. Everything that is around you is a vertex, and when you move your camera, everything's just kind of moving around the camera, not the camera moving the objects. So, what we're going to do is implement that. So for me to do that, I just want to show you something. I made this. So we have this scene of all parents. So I know I'm bad at this game. I should probably draw this better. Anyway, so we have the scene up here, and then we have these nodes, right? These are all individual nodes. And what we're going to do is pass the model view for the scene, or for the camera, basically. So we'll have the camera in here. And the camera is how we're going to control all the numbers associated with the model view and the projection. We're also going to have the projection in here. But we're going to pass the camera's model view down here. And that's the parent model view times this node's model view. And then this node's model view would be so if this is rotating in space, if this is some square rotating in space, well, everything that's attached to it, all of its subnodes need to rotate too. And so we're going to take this, multiply this model view, get this model view, because with the camera, it's called the view matrix. So when you're utilizing the camera, the model matrix is attached to the camera is the view matrix. And the model times the view matrix. So you're going to take it's actually more the view times the model, and you're going to take that, multiply it down to the children, and then those children to their children, and then everything will kind of move around the camera because it's all rotating. Like I said, if this is rotating, all of these are going to rotate with it. If this is rotating, well, all of these are going to rotate with it. You see, that's kind of how it works. And the scene's just going to move everything around. So, really, what I said before, now that I'm talking myself through it, it seems kind of like it's picking up objects and it's moving them. But, yeah, so I guess it is. It's levitating objects. I don't know. Think of it in your own way. I think it's more levitating objects. The more I'm talking about it now, the more it's levitating objects. Anyway, all you have to know is that we're going to pass the camera's model view down to the nodes. Sorry if that description was freaking annoyingly annoying. But let's continue. So I'm going to create the camera. So we're going to go here, Swift file, call it camera. It's going to be some We're going to import metal kit class camera. Sorry, I gotta get some water. That's better. So class camera. Next thing we're going to need is, like I said, we're going to need a projection matrix. So var projection matrix. Instead of keeping this projection matrix in the scene, we're going to put it into the camera. See, you notice that before we did it here, well, no, our scene is going to have a camera now. Just instantiate a camera, and then we're going to take this, cut it, and say camera dot projection matrix. See that? And now we're going to go back to our camera, wherever the heck I put that. I'm going to put that up in node, because it is a node, technically. So we're going to call it a node, because we want it to have a model view, or, yeah, like camera model view, kind of. Class camera, what's going on here? Has no initializers. Oh, it's because I'm not doing this. So we're going to return what I cut before. Oh boy. Right there. And you'll notice we don't have an aspect ratio, so we're going to need that. We're actually going to need all of these numbers, because now we'll be able to just control the camera's numbers, and say like camera.FOV equals this, camera.aspect ratio equals this. So aspect ratio float equal. We'll put that to 1 right now, so now that will be happy. We're also going to need var FOV, which is a float, equals 1. No, 45 in this case. Let's just set it to what they are right now. Var near z float equals 1. Var z float equals 100. And I'm going to put this to 0.1 like we had before, because why not? And then this aspect ratio is now going to complain. I spelled things wrong. We're going to put this FOV right here, this near z, far z, and boom. So if I run it, we also have another external, something's calling aspect ratio, I think. Yeah, we're setting the aspect ratio on resize, so that'll probably be in renderer. And or right here, yep, see, so instead of scene dot aspect ratio, we can just say scene dot camera. Oh, I guess scene has an aspect ratio still. Delete dot, oh wait, what the, why are you compiling? What are you doing? Alright, there you go. And now we'll go back to the renderer and say scene dot camera dot aspect ratio. And there. Now if we run it, we have our camera, which has a projection matrix, and bada boom. Camera can't really move around yet. We can zoom in and zoom out, but it's just working like it should normally with this projection. So there's that. Let's go ahead and go back to the camera. And for the model view, basically, so the camera has a view matrix, right? So I'm going to call it var model view, and then I'm going to return a matrix float 4x4, which will just return return model. Wait, this will be, we'll return not model view. This will be the view matrix, and yeah, so then we can call view matrix times model view of the other things, and I think that's good. You don't like that, really? Return. What the hell did I name it? Model matrix. This will be the model view. View. Model matrix? Oh my god, I forgot already. I'm tired. Model matrix. This will be the view matrix. Sorry. Alright. Yes, so now we'll take the view matrix, which is basically the camera's view matrix, like whatever we've done to it, so we can call camera.position equals camera.position.z equals -80, and it'll be way far back, So that's how that's going to work. And now we can utilize this view matrix by passing it down all the way from scene to its lower level people. So instead of using this override function, we're going to need to now just call render. And we don't need this delta time because you see we're not using it anywhere. We're going to just pass in we're going to use the delta time just in case we need to update. Sorry, but we're going to go down here to the node class, and the node doesn't use delta time. That's only the upper classes, because remember we got rid of the override. We're going to put this. We're going to go here. We're going to go model view or parent model matrix float 4x4, and then we're going to render, instead of rendering with delta time, we're going to just render with parent model matrix, and we're going to go this is the node, so we can multiply this now. So we'll go maybe yes, no, that's right, we're good. So command encoder, and then we're going to go parent model matrix, just like so. Okay, and yes, that looks beautiful. Okay, so now let's go back to our scene. We're not going to want to call super.render anymore. We're just going to want to iterate through our own children. So for child and children, we're going to child.render. What the hell is going on here? Something's up. See, what did I do wrong? Something's weird. For child and child, something's up. So we have the projection matrix. Now we need to pass down to our children. Oh, for each child? That's not how it is. Children? What the heck? Act like you've written a for loop before. Let me see what's going on here. Where's my children? There's my children. I'm doing it right there. For. And it could just be taking forever to. So we'll go child.render. Command encoder, and then we'll pass in, because this is the parent and we want that parent parent matrix. We'll go camera.view matrix. See if this renders. I think it's gonna break, but hey, yeah, what is going on here? Oh, what? Missing argument. Oh, I need to put parent model matrix. Yeah, my IntelliSense is just being really slow for some reason. Okay, so there's that. Hopefully that works. I don't know why it's being so slow. Anyway, so now that works, we probably won't see anything. I guess we will, because we haven't really changed much. So we're still calling it, still doing delta time, still rotating everything, just like here. Beautiful. But now what we're going to do is we're going to take this camera.view matrix and multiply it down all the way. So in this renderable.draw, so we're going to do child.render. We're just calling this on everything. And then so when we draw it, we're going to multiply the model view times that. So we'll go let model view matrix equals my matrix multiply. Oh my gosh. Actually, I remember how to type things. You kidding me? We're going to type in parent model matrix, and we will go model matrix. Maybe. What's going on? Oh, maybe I gotta declare it? I don't know. Matrix. float 4x4. What's up, dude? Matrix multiply? Yeah, there it is. Okay. Whatever, man. This is insane. All right, so there's that. Now, we're not using it, but we're going to be passing it into this drawable. So let's go to our renderable, and in the draw, we're going to now take in the model view matrix as a matrix float 4x4. Okay. And we're going to need to conform to it in our primitive and say stuff like draw with our model view matrix, which is our view matrix times our model view matrix as a matrix float 4x4. And instead of saying model matrix, we're going to just say model view matrix, and that's it. Okay, I'm going to press play, see what happens. Nothing should show up because our camera should be right in 0. Oh, yep. So this, and we got to pass in the model view matrix. Model view matrix view. Yeah, you know what's up. Thank you, IntelliSense, for finally working. So now, if we go all the way through, press this, nothing's going to show up. That'll be a good thing. Oh, well, no, I guess it is. It'll show up because it's 0, 0 still, and the cube is at negative still. So, but when we go back to our scene, now we have a camera. So in my camera, I'm going to go like camera dot position dot z equals -20. So now you'll notice that the camera moves backwards, right? Look at that. Look at how like the camera moved backwards. And so, you know, lighting still works exactly the same, which is awesome. But the camera is now off in the distance, and the model is moved. So let's put the cube back at position 0. So the cube doesn't move. We just add the cube at 0, 0. And see, it's right there. It's at 0, 0. But the camera has moved back. Now, so in order for this to actually like look legit, let's add some key input. So I'm going to add, okay, so I'm going to actually need to pull up a list of keys. So the ways this is going to work, I don't know if you've ever done a game engine or like a Java game engine or any sort of engine before. There's a really good way of doing key input, and I just need key code values. Swift. See if we can find some. I should have found this before. I think yeah, like I was looking through this earlier and I found one and I forgot to bring it up. Let me see. One of these fine gentlemen posted something awesome. We don't want to just say, we want to say, we'll hard code it, but we want to make it at least an enumeration. And someone put, okay, give me a second. Let me see. Yeah, these guys aren't helpful because, like, I couldn't find. Oh, right here. So this is going to have all the key codes, like those right there, boom, that we'll need. So I'm going to put you off to the side right there. I'm going to put you in front. I'm going to shrink you a little bit. And I am going to take a drink of water. So we're going to use those keys. Each key, like key B, key Q, these are the keys on your keyboard. And you see they have an integer value associated with them. So that's the number that's associated with all sorts of virtual key codes. This should be universal, I believe. But not universal, but like for, you know, American standard keyboards, these numbers should work just fine. If you don't have a standard keyboard find your keyboard and figure out what your keys are. My throat's getting dry. So we're going to go up to Window. I'm going to create a new file. I'm going to make it a Swift file, and I'm going to call it input handler. Okay. We're going to have an enumeration, enum, and that will be key values, input values, key code. How about key codes? Yeah, key codes like that, and then let constant. Right, it's constant let. I think constant let constant. I can't remember how these go. So is that how you do this? I can't freaking remember. I'm gonna have to look this up. Let me see what's up. Come on. Oh boy. Gosh, I am not doing so hot. How do you do a freaking enumeration? I'm gonna look it up. Is what I'm gonna do. Enums in Swift. Enum types. Case A, case B, for example. Where are you? Let's try this. If this doesn't work, I might need to research into my own stuff. So we're going to just take that, type key, underscore codes. It's not going to be a character, it's going to be an int. And then this will be A equals 1, 2, 3. Now do you like that? Is that alright? Cool. Key underscore we'll do the so yeah, let me think. All right, so WASD could be used to like move one thing around, like the model around, and the arrow keys could be used to move the world around. That's what we're gonna do because I'm bad with keyboard stuff. So we're gonna call key W, and then we'll go key underscore S, yeah, key underscore A, and case key underscore D equals 4. All right, so what are these equal? Let's see here. So if we go to this, we'll notice that, well, A equals 0, I think, yeah. And then S equals 1, W equals 13, and D equals 2. So now we have these key codes, right? Maybe, yeah. So we have key codes. Cool. We're also gonna need to get like we can put. I want to make this class have a lot of like static functions. So that's what it's not constant static. Let static or static let static let key W equals that. See, that's how you do it. You can do it that way too, but whatever. So we're gonna need to get a couple of little functions here. So how about func get mouse position? I want to put that over here. So we're gonna have the mouse position here. Then we're also gonna say func is key pressed. And we'll pass in a key and see if it's pressed. Also, so input handler will need, so there's a good way to do this is to use a list, a long list, about 256, because that's probably as high as it goes, booleans, and then triggering those on and off, and then asking if that is on every single time. So that's what we're going to do. I don't know if you know what I'm talking about, but I'm going to continue through. I'm kind of tired today. I'm sorry, peeps. Just want to get this rolling. So input handler, we're going to have var key key list. I don't know. That was a terrible name. Which will be an array of boolean equals bool dot init. Can I do this? Yeah, but I think I want to do init. There's a cool thing you can do, dot init. If my IntelliSense would work, give it a second. Oh my god. Yeah, init, repeating. It's like, oh god. Let me see, repeating. Oh yeah, so the repeating is going to be false, so everything's going to be set to false initially, and then we're going to do this 256 times. And we're actually going to declare var key count static var. Well, private static var key count equals 256, and we'll just call it key count. Maybe. Cool. All right, Danielle. So now we have our key. We have our Boolean list, an array of Booleans that repeat with false up to 256 times. So we're going to pass in a key code, right? So let's do that. Let's pass in the key code. So key, and then we're going to pass in the type key codes. And if, and then we'll say key list at int key code key equals 1, or well, we can just return that. Maybe. Yeah, I think this is going to give me issues because I can't remember. Oh, it's dot raw value. And then we can just return key list bool. Return key list equals 1. Right? Is that going to be cool? Be cool, bro? Let's see. Equals true. Yes. So now we're checking at the key list at this value. So if key, I don't know, S is pressed, so key 1. So we're checking at the index of 1. If that's pressed, if that's equal to true, and then we'll have to have a way of setting that equal to true. Right now it'll just return false every single time, so the key won't be pressed. I'm going to do this, get mouse position, float 2, and then we're going to return whatever I have on the renderer, because, am I doing it on the renderer? Yeah. Renderer's job isn't to keep track of the mother trucking. So, func update input, update input. We're going to create a function called update input, and then we're going to call that, because this will have an input handler. Renderer will have an input handler, not a mouse position. So var input handler equals input handler. Okay, so now we have an input handler, and then we will set, so input handler dot, we're gonna go, no, we're not gonna do that. That's ridiculous. That's too much effort. We're not gonna do that. No, input handler will have a function called func set mouse position. And then we'll have a mouse position, so mouse position float equals float 2. And then we'll just update this mouse position. So we'll take in position float 2 mouse position equals position. And then we'll say self dot. And then this will be private mouse position, so we won't be able to get it, and it'll actually be a static because this function will be a static. So this function static. So all of this stuff, private static var. Cool. So is everybody happy? I think this should be good. Oh yeah, I guess we're going to probably need to import MetalKit. Doesn't know what the hell a float2 is. Func static. Let me see what's up. No. Static func. Silly me. Func static. That sounds like a band name. This will return mouse position. Which will be static. This will be anyone can access these at all times. Boom. Cool? Yes. Cool. See, so now the renderer can call input handler dot set mouse. Oh. What are you doing? That's private. How do you get into that? This is static and it's available, but this should be just set mouse position. So we're going to go input handler dot set mouse position. I wonder what's up. And then we'll call, this will be position, and we will say float to, just real quick because I don't want to test it. My IntelliSense is acting like dookie. Alright. All this stuff we're just going to put up top. Probably need the view. Don't need the view. Okay. All right, so let's update this. Let's see. Let's press play and see what fails, what doesn't fail. Maybe we'll get lucky. Yep. All right. So here we go. View dot bounds dot height string has no member bounds. View. Yeah, we do need the view. So view mtk view. And then right here I will call update input on view. Just like so. Scene.light position. Shouldn't that be in the freaking... Yeah, what is that doing in here? It should be in the light, or in the scene. I'm just going to comment you out. Okay, and we're also going to go to shaders, and I'm going to comment out this for now. Just take it. No, I'll comment it. And just take this part. View.balance.height. What is your deal, bro? That's what I meant. Position X is. I'm just gonna go like this. I guess I could put that in. Cool. All right, so it's still working. Ignore the light position thing because we're going to put that. I'm going to actually do that right now. So take this out. We're going to go put it into the scene. So if you have light there, you can just go like this. Light.light position equals input handler.get mouse position. Now that should give us the mouse position. Let's make sure it renders. Man, this non-IntelliSense is being a bummer. Alright, so that should be still good. It's still doing mouse position just right. Freaking A. Let's see. So let me see. Metal view. Where is it doing that? So if we go to the renderer, where's it doing that Swift.print? Input handler? Where are you printing out my input handler? That's that mouse position. I don't know where the hell it's doing that. Where are you printing out these? Metal view? Yes, you are. So that's cool. Well, I wonder, let's go like that. Let's go to the renderer. Let's actually go to my scene. Nah. Alright, so I'm gonna do that. Let's actually go back to the metals stuff and comment this one. I'm not gonna have light after this. I just want to test it. See if it works. Yeah, okay, so now we have this light position in the scene where it should be. I don't know why I didn't move that. But what I'm going to do is I'm going to comment this out and just use this one for now because we'll want to see the whole scene. So there's that. This is good. I could probably just call input handler. Like, so this metal view doesn't need it anymore. So we'll say, let's pass in this guy. Because the metal view shouldn't have any mouse position. There. So now the metal view get mouse position is gone. So now in my renderer, input handler, we don't need this. This already happens. This will basically be what happens. Trying to think, do I actually need? I'm calling get mouse position and then set mouse position. That doesn't make any freaking sense. I'm going to keep that in the metal view. Okay. Now everybody's happy. I'm going to keep that there too. Renderer. Cool. So we get in the mouse position. I might fix this later. Yeah, definitely gonna fix that later. Let's just make sure it runs. All right, so there's that. Unuser 11.10.3. Boom. Okay, so we have him. We have him. Let's check out this input. So there's something we can actually do now that we have this input handler .get mouse position, and that is inside of our basic scene. Well, we know what our width of our scene is, or what our view is, right? That's like 800, and I can go check that here. So our view is going to be slow right here. It's 800. So our width is 800 and our height is 550. So I know that. So if I go, so how about let position equal camera dot, no, input handler mouse position. That's what this is. Equal camera dot get mouse position. That's not right. Input handler dot get mouse position, and then I can say camera dot rotation dot x equals, well, when our width, so if the x is at like 50 and we divide that by the width, it's going to come out with like, let me just kind of check my math. Where am I? Yeah, so if we're at 50 and the width is 500, it'll be 0.1. Just making sure. Thought that's true. So what we can do is we can say mouse position dot x over the view, which is 500. 800. It's 800 is the width. So if I play this, you'll see, I'm just gonna, oh, nothing's happening. Oh, something's happening. Oh, it's because it's rotating. So let's stop the rotation for just a second. Actually, no, we're not gonna stop the rotation. We're gonna add another. So how about let's C2 cube, same stuff. Do this a lot. C2. C2 dot position dot x equals -3. Okay. So now we'll have 2. This one won't rotate. C2 won't rotate. This one will be rotating, but you'll notice that there's a model rotating, and then we can rotate the camera. So let me see. Maybe I didn't add. Oh, I didn't add it. Nice convenient way of adding things. So now you'll notice that we like have, oh, what is it doing? Oh, it's rotating around the x-axis. I meant y, because it'll rotate like along the y-axis, which is up and down, so it'll rotate along that. X would be exactly how it was. But you see now, look at that. And you'll notice, like, they're both rotating, right? Because the scene, the camera's controlling the whole scene. You see, it's rotating with it. So if I do that same exact thing with the height, which is 550, and this would be position.y, see, we're rotating everything together. The whole scene is rotating. Isn't that cool? So we'll be able to walk through this in no time. This will be like a whole world we can walk through. We don't actually, but like, so we can rotate around the scene. That's cool. We can't really move the scene. We can just rotate it. We don't have like any cool way of making it keep rotate if we're all the way over here. If it just kind of keeps going. I'll probably do that in a different episode, but like for now, we have rotation and we have mouse input and we have the camera, so that's good. Let's get some key input going. So key input will be done on the metal view, and it'll be just like mouse moved, except a little bit different. So first thing we'll need to do is declare an override var accept first responder, and we're going to return true. So this will be the first responder. I really don't know what this means that much. I'm assuming it just means like it is the first screen. So if it's on the screen and you click a button, I'm like that, like accepted. And now we can write this these functions. So I'm gonna take this guy and move him down here because I want to, and then mouse moved, and so that'll be the first thing, and then we'll go override func key down, and then we're going to do the same thing key up. So when it's down, you know we're going to add the boolean to that list of booleans, and when it's up, we're going to add it to up. And I love IntelliSense. Because it's blazing. All right, so now we have that key down, key up. So in our input handler, we're going to need to set key. So we have a set mouse position. Now we'll go public static func set key down, or key pressed. And we'll say is on as a boolean, boolean, just like so. And we'll say key list at is on, and then we'll say key, and then this will be a key code if key list at, well, we'll just take this, equals is on. So it's going to set it on or off, right? So we'll take in if it's on, or let's do this first. Let's do key code first, and then we'll say if it's on, just like kind of a standard that I've done in the past. All right, so there we go. Now we have a key is on, so key list, we're just setting that to on. So now in our metal view, we can say, well, key down means key is on, right? And then, so I can say var key code equals event dot key code, right? And that's just a number, uint16. So what I'm going to do is just say input handler dot set key pressed, the key code, or well, I guess int. It doesn't take any key code. It'll just be a nice uint. I'll just say key code. This would be key. I'll just put key. It's not the key code, it's like a number. Key list at key, which will be an integer. So it'll be a uint16. And let's just make sure this works. I guess I gotta go int. All right, everybody's happy. Nice. All right, so now in my metal view, I can say key at, well, event.keycode is on, well, down is true, right? And then we're just going to do the exact same thing that we did here, right here, except we're going to say false because you let up on the key. The key went up, so it's false, key down. So in our loop, our renderer loop, when we say update input, we can not worry about this. Trying to think. Okay. Yep, this is good. So now in our basic scene, we can say so c.rotation. We'll keep that. Oh, Let's do this. Okay, so we'll need func update input. This will update the input, and we'll call that every single time right here. I'm going to just, and then I'm going to pass in delta time. And then I'm going to put everything that's here, and if you haven't noticed, we can take this update input, just put it in the scene, because we're probably going to do it in every single scene. So I'm going to go func update input, it's empty, and then in basic scene, we'll go override func. I don't need to. And then in scene, I'll need to make this take in delta time float. Cool. So now, in my scene, I can just call right here update input with delta time. Delta time. See that? Yay! So it's going to do exactly the same thing, except now we're going to be updating the input easier. So let's see. Boom. Same stuff. See? Still doing the same exact stuff, just now we have it in, like, kind of broke out a little bit more. So now that we have this update input, let's write like a little if. So if input handler dot is key press. We have these key codes, right? So I can say key S, I guess, or key codes. I gotta call key codes dot key S, or I guess I can do a select statement. I'm just gonna do it this way. So if, so this will be W, key W, S, D, A. So this will be W, so we'll want to move the cube, right? One of the cubes, so C, which is we'll do C2. So C2 dot position dot, well, we're doing W, which is up, so we know that our position dot Y needs to increase, plus equals, and we'll just say, I don't know, 1, 2. We'll just say 2, right? And so let's just go ahead and test that out. So now, so when I press W, it should move up. Whoa! Okay, well, we can't move it down now. That was really fast. 0.5. Oops. Let's put that back down. Do not make it 2. It's going 60 frames per second. So let's press W. Oh yeah, W. Look at that. But I can't. I can't move it back down yet. So let's move it down. So if it equals S, we'll do minus equals 5. So let's move it up and down, and we may as well just put these. So this will be X. So if we press D, which is to the right, we're going to want to increase, and then we'll want to decrease, going the opposite way. And I think that's right. Could be wrong. So WDSD. Oh yeah, look at that. And then you can like kind of rotate it. Oh, cool. Make like a little. If you press 2 at the same time, it does an angle. You see that? Let's see. Cool, huh? It's fast. Maybe it's too fast. Looks like Snake. Maybe we'll make Snake. Pretty good first game. All right, so so that's working. Now let's get so I'm just gonna put this here, and I'm gonna do this. Give me a second. Whoops. I mean, I'm gonna also declare the 0.5 like speed or something. So we're gonna make a var speed as a float equals 0.5, and I'll just say speed here. Oh man, I don't know how that works. So that way, if I update the speed, I don't have to go through every single one. Cool, so this will be model. Down here, we're gonna do the camera. I know we don't have a Z, we should probably have a Z. What about Z and X? We'll make it Z and X. Yeah, so it can go back into space and not just around that two planes. So input handler will need to add two more keys. So we're gonna go Z and X. I don't know, what are they? Q and E. Yeah, we'll go Q and E because they're kind of, I don't know. Zoom in, zoom out. It's not really because W is usually zoom, like that's usually Z. It's left and right. There's, I guess space would be up, but we'll deal with it in a second. So let's just we'll do 1 and 2. How about that? 1 and 2 will be zoom in, zoom out. So key 1 is on the side. That is going to be 18. Key 2 is going to be 19. See that? Simple. Let's go back to our basic scene. Boom. We're just going to copy these because we're going to have like the same type of stuff. Oh, we're only going to have 2. Oh, no. What am I doing? We need 2 more. 2 more for this guy. So we have 1, 2, and we'll say Z is zoom in, so it'll be minus equals. Kind of confusing. And then plus equals. So let's zoom it in, see if this 1 and 2 work. So 1 should go back, 2 should, yeah, perfect. 1 goes back, 2 goes forward, WDSD. Cool. And you can do whatever you want with that too. You can say like camera dot FOV equals like something small, like 10, super zoomed in, zoomed out. So it'll be way back there more so. So look at, oh, well, more close. Excuse me. Getting everything wrong today. Ah, it's one of those days. All right, field of view is 70, so it should be zoomed way out. Boom, way off in the distance. Look at that. Cool, huh? And then, if you notice, if you just zoom out, you probably already did this. Go all the way back to 100. Oh, gone. Oh, right there. You see that? So cool. All right, so I'm going to actually get rid of this. It wasn't that cool. But now, so that was the model. Let's do camera. So camera is going to have the exact same stuff. Right? It's going to have X, Y, Z movement, except we're going to apply it to the... Let's only do 4 of them. We'll do arrow keys. Yeah, only arrow keys. Go Z's and X's. So you're only going to be able to move through it. And then when you rotate... Alright, yeah, let's try that. Let's see what happens. I don't know if I have a look at type function going yet. I don't at all. All right, I'll need to figure out how to do that. Get back at you. Okay, so we'll need 4 more. And that will be key, arrow, right, or up. We're going to copy this. Down, left, right. Down, left, right. Cool. So now arrow up. 126. Down is 125. Arrow left is going to be 123. Right is going to be 124. Okay. So now, beautiful. Go away. Okay, so now that we have those, we can go to our basic scene and just do that. So this will be, let's copy these guys again. Up, down, left, right, down, left, right. Okay, now we're going to do camera. Camera. Oh. Copy and paste it. Copy. Copy pasta. So the camera dot position. So if we press up, we want our Z. This will have to do with our Z. We'll want to decrease because we're going to go forward, right? And then our camera dot position dot Z plus equals if we press down. Left for our X, we want it to decrease, and Y will be right there. We'll go plus. And now let's try that. Let's see our camera move. My nephew's in the hospital. He's doing okay though. Okay, so you see, look at the freaking scene. Oh, we move. Oh, that's inverted. That is inverted. This is plus. This is minus. See, so we got our whole scene moving. So like if I do this, you see I can move that. One guy, model, else move everything. And also, so you see how this cube is rotating? Well, let's go to the cube. Let's, can I see how I see that add? Oh yeah. So I'm gonna create another cube for the cube that's rotating. So I'm gonna go let inner C cube. So we're gonna have a cube rotating with, just so I can show you that kind of how the camera's working. So inner C equals cube device, and then we're gonna add. Oh wait, no, we're gonna go C dot add. Inner C. See, so now that'll be there, and then we're gonna go inner C dot position dot X equals -4. No. Yeah, like -4. So that's relative to the cube. Oh, what did I do? Oh, okay. Probably should do that, huh? Oh, well, let's do C2. That's what I meant. So who's rotating? C? So we're going to add C. This looks kind of janky, I'm sorry. Let's see what this looks like. So, what are you doing? I'm just gonna see what happens. Okay, yes. So that's the idea. That one's so it's rotating, but look at, like, it's separate from this model. If I were to move this one, it would rotate, it would move that one with it. So let me see. Boy. So I'm just gonna go like this. C2.add inner-C. Try and prove a point. Okay, maybe I was wrong. Okay, screw it. But it's rendering. Why is it not? I'll have to dive into that and see what's up, because I'm pretty sure they're supposed to be rotating together. Like, this is supposed to be like rotating around that one as it's moving, but something's up. All right, so let's get rid of this inner-C bullshit. That's a lot. Cool. All right. So we want to init. I'm gonna get rid of this too because it's just sloppy. All right. So this episode, which is at 107, still a little long, not the longest. We now have user mouse input that's kind of working a little bit. And we have our camera moving. It's not really moving throughout the world, which is kind of weird. I think these are inverted. Yep, up and down is inverted. Fix that. Just make sure these are good for the next episode. Probably go into a little more advanced stuff for this. Let's do that. That looks better. It's a little bit more intuitive. Yeah, and then we got our model. Okay, cool. So, yeah, that's about it. It's freaking sweet. All right, guys, that's it. Yeah, I'll see you when I see you.